With metabolic alkalosis, alkalosis refers to a process that raises blood pH above 7.45. And metabolic refers to the fact that it's caused by an increase in the concentration of bicarbonate, or HCO3- in the blood. Normally, blood pH depends on the balance or ratio between the concentration of bases, mainly bicarbonate, which increases the pH, and acids, which decrease the pH. The blood pH needs to be constantly between 7.35 and 7.45. Now, metabolic alkalosis can typically happen from two main causes: loss of hydrogen ions and gain of bicarbonate ions, or most often a combination of these two. Loss of hydrogen ions can happen either from the gastrointestinal tract or from the kidneys. The first case most commonly happens during vomiting, because the gastric secretions are very acidic, meaning that they have lots of hydrogen ions. On top of that, normally as gastric secretions flow into the pancreas, they're met with bicarbonate secretions, which neutralize the acid so that the various pancreatic enzymes like trypsin and chymotrypsin can work effectively. So during vomiting, not only is the stomach acid lost, but in addition, the pancreas doesn't secrete bicarbonate into the intestines, and so it builds up in the blood instead. Another way that hydrogen ions can be lost is through the urine, in the context of having too much of the hormone aldosterone. This can happen when there's an adrenal tumor that secretes excess aldosterone. The aldosterone makes the alpha intercalated cells of the distal convoluted tubule and collecting duct dump out hydrogen ions and reabsorb more bicarbonate. The result is that the urine becomes more acidic, and the blood becomes more basic. Now, the second cause, a primary gain of bicarbonate, is usually caused by an increased reabsorption of bicarbonate from the kidneys. There are various things that could stimulate the kidneys to do this. One of them is volume contraction, or excessive loss of extracellular fluid, which can happen with loop diuretics and thiazide diuretics, as well as in cases of severe dehydration. The resulting alkalosis is called a contraction alkalosis. Sometimes dehydration happens in combination with other causes of metabolic alkalosis, like prolonged vomiting. Another stimulus is hypokalemia, or decreased levels of potassium in the blood, which can be due to excessive loss from the gastrointestinal tract, like in diarrhea, or from the kidneys due to diuretic use. In any case, when there's less volume or less potassium in the extracellular space, it triggers the renin-angiotensin-aldosterone mechanism. As a result, angiotensin II and aldosterone levels rise, and the kidneys start to retain water and reabsorb more bicarbonate in the proximal convoluted tubule. In addition, the alpha intercalated cells of the distal convoluted tubule and the collecting ducts secrete more hydrogen ions into the urine. But most importantly, they also make new bicarbonate ions, which will again get reabsorbed. Now, in other cases, excess bicarbonate ions don't come from within our bodies at all, but are ingested in large amounts, usually in the form of antacids, like sodium bicarbonate. These are typically used to neutralize stomach acid and relieve indigestion. Excess use of antacids, though, can result in more bicarbonate ions than hydrogen ions in the stomach, and the excess bicarbonate ions can get absorbed into the blood. All these processes have a net result of increasing the bicarbonate ion concentration in the blood, which increases blood pH. But in addition, there's often a hypokalemia. In vomiting, for example, potassium ions in the gastric secretions are lost. In other situations, there's an increase in aldosterone, like during a contraction alkalosis or when there's an adrenal tumor. The aldosterone can affect principal cells which line the distal convoluted tubule and collecting ducts, making them excrete potassium into the urine. So essentially, hypokalemia can be both a cause and a result of metabolic alkalosis. Now, if there's an increase in the bicarbonate concentration in the blood, the body has a few important mechanisms to help keep the pH in balance. First, cells throughout the body have a special type of ion transporter that exchanges hydrogen ions for potassium ions across the cell membrane. Using this transporter, the cells can shift hydrogen ions out of the cells and into the blood, and in exchange pull potassium ions out of the blood and into the cells. And this can contribute to the hypokalemia. Another mechanism involves the respiratory system and starts with chemoreceptors that are located in the walls of the carotid arteries and in the wall of the aortic arch. These chemoreceptors fire less often when the pH rises, and that notifies the respiratory centers in the brainstem that they need to decrease the respiratory rate and depth of breathing. As the breathing becomes slow and shallow, the minute ventilation decreases, and that's the volume of air that moves in and out of the lungs in a minute. The decreased ventilation slows down how much carbon dioxide leaves the body, increasing the partial pressure of carbon dioxide in the body, which decreases the pH. A final mechanism is that if metabolic alkalosis isn't caused by some renal problem like the use of diuretics, or extracellular fluid volume contraction, then several days later the kidneys usually correct the imbalance. The kidneys retain more hydrogen ions while also reabsorbing less bicarbonate ions, so that it's more easily dumped into the urine. Alright, as a quick recap, metabolic alkalosis is caused by an increased bicarbonate ion concentration in the blood that elevates blood pH above 7.45. This most frequently results in loss of hydrogen ions due to vomiting or adrenal tumors, and less commonly from a gain of bicarbonate ions from antacids or volume contractions.